This video is totally optional. You can skip it if you'd like. I decided I did want to say just a couple things about this handout that's posted in Canvas about the geometry of secant, tangent, cosecant, and cotangent, and where their names come from. I'm not going to go over this in detail. You can read through the details on the sheet, but I just wanted to talk about what the sheet, what the point of the whole thing is. So there are a few diagrams with angle theta in standard position and certain sides labeled with values of the trig functions. Now, I think historically people were probably thinking mainly about acute angles for these pictures, so we're mainly dealing with first quadrant situations. But in this first picture, you can see lengths that are equal to the secant and tangent of the angle theta. And notice that secant length cuts across the circle. So it's a line that cuts through a circle, like a secant line cuts through a circle. And the length that the tangent represents is the length of a line that touches the circle at one point. That's a piece of a tangent line of a circle. So secant theta is a piece of a secant line. Tangent theta is a piece of a tangent line. The sine is also drawn here. And as far as I understand, the word sine comes from an old Latin word for chord of a circle. A chord was a line connecting 2 points on a circle. And the sine is actually half of a chord. So if you go from this point straight down to here, the sine of that angle is a half of that length. So in a sense, a sine is half a chord. At least that's what I've always heard. Now, as far as cotangent and cosecant and those co-words, really the cotangent is just the tangent of the complementary angle. And the cosecant is the secant of the complementary angle. So in this picture here, here's theta. Up here is the complement to theta because they would add up to 90 degrees. And so this is the secant of the complement and the tangent of the complement. And that's where the cosecant cotangent language comes from. Okay, just you can read this over in detail to get things explained maybe a little bit more thoroughly. I tried to write it all out here. But there is one other picture that's just sort of a very kind of interesting and fun picture to look at where the relationships don't have the same kind of geometric meaning, but here's a unit circle with an angle theta in standard position, and there are lengths that represent each of the 6 trig functions of theta. Now what I haven't explained is why these lengths equal those things. You'd have to either read the explanation on a handout and even then I just say think about similar triangles, think about ratios. So there is work to do in figuring this out. And again, you can take it or leave it, but it is my attempt to kind of explain why we use the words secant, tangent, cosecant, and cotangent.